Alright folks, this is going to be a video basically covering how I went about putting the DRO on this machine. It has a X-axis, Y-axis, and Z, and how I went about mounting the slides. And this is sort of by request. I had someone else who had just gotten one of these machines and was curious how I did it, so I figured I'd take the time and show at least how I did it, what worked for me, and that might give them some ideas how they might go about it. First of all, I'll say all the slides that I put on this are eye gauging. You can buy them on Amazon. That's where I got mine, and they come with these. Every slide will come with one of these. I've never used them. Instead, I chose to go with blue DRO. It was actually after I came across blue DRO that I decided to actually do this to this machine. Blue DRO allows you to connect these eye gauging and I think maybe some other slides to a box that you can buy, the blue DRO unit, which will transmit them via Wi-Fi or Bluetooth to an Android device. This is the tablet that everything is transmitted to. I got you handheld right now, so it might be a little bit shaky. This is actually an Amazon Fire 7, I think, tablet that I converted to be able to use other apps. Basically made it a true Android tablet, and it works quite well. This one just lives here. It doesn't do anything except perform as the DRO. I actually made a little articulated arm and have it mounted up above the machine where I can see it easily. Now, I actually chose to make my own circuit board that's inside that box. You can see the Bluetooth module blinking. There are instructions on the website, yuristoys.com, I believe it is, to actually build your own using an Arduino. Okay, the slide for the Quill, it was kind of hard figuring out where to put this, but I put it up here behind this cover. You got to take this handle off. This handle is held in with this tapered pin. It only goes one way, and 90% chance if you knock it out of there, it's going to wind up somewhere like where I just had to retrieve it from. This lived underneath my machine in all the metal shavings for about the last half hour that I searched for it. Truth be told, I filmed this once before and I wasn't happy with it. And I lost it that time too. Okay, this cover has a screw here and a screw here, which I've already taken out. Okay, this plate basically it wouldn't have to be this big. But this over here, these 4 holes were made to hold a stepper motor or a servo motor. These machines, you could get a CNC kit for them. This one didn't come with the CNC, all the motors and gizmos, but it did come with all the mounts and sprockets. So if you wanted to buy the remainder of the kit, you could make this machine CNC, but by today's standards, it's impractical. This plate can be removed. There's 4 screws. There's one behind here. I made this bracket. This reader head is bolted down here, and these holes that I used already existed. They're 6mm 1.0. Now, again, in trying to keep everything running straight, I made the bracket so these holes are a little bit sloppy, so I could wiggle this side to side to get this alignment. As far as down here, I just have washers stacked up. What I did is I ran the quill down and I pulled this down, measured the distance, brought them back up, measured the distance. It was straight, which it would almost have to be because this plate is mounted on there true. So I just put spacers back here, and that one screw is all that holds it. But it hasn't come loose in the, I think, 2 years that I've had it on here. So the wire I just have routed through. This is actually the shaft hole for the motor. And I put a piece of hose in there to keep it from getting chafed or beat up. Now, when I bought these slides, I think I got something like a 1 foot, a 2 foot, and a 3 foot, and I had to cut them all. This one here would have hit the pulley if I hadn't cut it. But they tell you can cut them with a hacksaw. It's not a big deal. So that one, when I get to the full travel of the quill itself, there's still just a little bit of it sticking up there. I should also point out this cover. I had to notch out up here and for down here. Now this is extra wide because it actually has to clear the bracket as well. If you notch this, when it's back on the machine, there are times it will vibrate. You may have a strange noise that you're searching for. If you grab it, sometimes you'll hush it up. But anytime I hear noise in this machine, I think something's going wrong. And I heard this after I had done this, and I just had the thought maybe it's that cover, and lo and behold, it was. The Y-axis or cross slide, DRO slide, is underneath this piece of aluminum angle iron, which is there because it's on this side underneath everything that comes off that you're machining. Putting it on the other side really wasn't possible because the lock is over there, sticks out right about here. And if I'd put this over there and try to clear that lock, it would just be in the way. So the angle iron seals pretty tight against here, and the brackets that hold all this have holes in them for this angle iron to sit on. So it really doesn't get anything on it. Any oil that seeps through here will miss it. It'll go down here instead of on this. And the angle iron curves down in front of it. Not completely, but nothing really bounces up to get on it either. Alright, here you can see how I mounted this slide. These 2 holes I had to drill and tap. The bracket I made, and this is the original bracket, of course, that holds the slide. But kind of hard to show the back, but the back's really the same, with the exception the holes that I used in the back were already there. I'm not sure what they were originally for, but I didn't have to drill them. But the bracket's very similar. It has this piece that comes out to put the angle iron on. Now here you can see I couldn't put this slide. You see this bracket right here comes off of this reader head, and it's actually mounted to the machine back here, and that was to keep access. There's a nut down here, one on each side you can loosen. You can rotate this whole table to different angles, and if I would have put this right here, it would have gotten in the way of getting to that nut. Now I will say tramming this thing's a real pain in the keister to get it straight, and so I very, very seldom ever turn this table. I avoid it at all costs. But this is just a piece of sheet metal that I bolted to the back of this, and I don't know if you can see my high-tech spacer here. Basically just a nut that was the right distance, not to put any stress on this. And on each end, this is adjustable up and down. And I was real careful how to adjust them so that as this travels, it's never pushing down or pulling up on this, because this is pretty rigid and I think this would break before this would bend. One other thing that I wanted to mention, the wire from that sensor on the other side, I have a little bracket here I made to hold it because it needs to stay fastened securely to this top piece. So if you do want to rotate this table, the whole wire will go with it, and it's wrapped nice and tight around the front side there, out of the way of anything moving. But you can rotate the table if you want, and the wire will just follow it, and then from here it goes over to the actual controller. Now the X-axis is mounted on the front here. Now this is tapered. I didn't want this to follow that same taper, so I made these blocks. I think it's like 3 degrees, but the blocks are mounted. There's a hole here and a hole behind this bracket that actually bolted to the machine. Now I drilled and tapped this for those holes, and I'll tell you, this stuff drills funny. It taps funny too. It's cast iron or something like it, maybe malleable iron. I'm really not sure, but basically there's a block like this on each end, and I had to space it out to get around. These are actually handles that slide out for carrying the machine. Well, I don't need to slide them out, and they won't come out. You can't take them off. I imagine if you unbolted it and flipped it over, you could go up from the bottom maybe and take them out. I hadn't thought about it before I mounted it on here, but both sides are mounted on blocks like this to keep this basically level up and down. Now the X-axis on here is different than the other two. Those two, the reader head is mounted solid and the scale moves through them. This one, the scale is mounted solid, the reader head is on the carriage and it moves across it. Now, to mount this, I had to drill the holes at this bracket. I made the bracket, but I had to drill the holes in here to put the screws up through to mount it. And what I did, if you take these cap screws out, right here, there's one here and one over here. There's a dowel right here, but you can wiggle that off of there, and because it's on the lead screw here, it'll tip down. If you move the carriage out of the way, you can flip this all the way up on top of the bed and make this surface vertical, that you can drill the holes in it and then just put it back together. you do have to take the lock off as well. Okay, Blue DRO also has the availability and input for a tachometer. Now, because these machines have 2 motors, 2 spindles, you have to figure out a way to switch that. This is the pulley on the back of the lathe spindle. You can see up here I mounted a Hall effect sensor, and inside here I have magnets stuck pretty evenly. I think they move around a little bit at times, but it does not seem to affect the RPM. If you watch when a magnet passes, you see that light come on. Now, when I first wired this, I made some mistakes and the RPM just didn't seem right. So I got an electronic gizmo. You can put a piece of reflective tape on, point it while it's running, and it'll tell you the RPM. What I discovered, both in doing that and getting the wiring right for this tachometer, is the chart they give you to set your belts for your different speeds is not accurate. If it tells you it is, say, 420 RPM, it will actually be 500. And this tachometer matches the electronic gizmo that I bought, and so I believe that both of them being matching are the correct RPM. The chart is, I guess it's close, but it's just not perfect. But every speed is faster than the chart will tell you based on your belt position. This is the control panel on the left side of the machine. Here you have one of the belt charts that I was referring to. I printed them out on paper out of the manual, and I have one stuck inside the door over there for the lathe, and I have one mounted up on the wall, on a cabinet actually, for the mill. My solution to having 2 spindles is this switch. It's a 3-way switch. This way, the DRO will read the lathe RPM. That way, it will read the mill. The mill RPM sensor is right back there. I made a bracket that I had to drill and tap the housing here on the back side. Just put a screw in it to hold that. But the tip of that sensor sticks up inside there, and you can see the bottom of the magnets. Another thing to know is the magnets, the polarity matters. You see on the lathe spindle here, that light lit when the magnet passed it. If you put a magnet in and that light will not light when it passes it, just flip it over. Okay, that pretty much wraps up the DRO and how it's mounted, where I put everything, how I went about it. You can do the RPM other ways aside from Hall effect sensors. That's just what I did. I'll put links in the description for the Blue DRO unit, how to build your own, the Amazon tablet, that's easy enough to find. If I can find them, I'll put a link to the Hall effect sensors. The eye gauging slides must have gotten popular because I have to look and see what I paid for mine, but I found them on Amazon just looking around last night. And the set that I got, regardless of what I said earlier, because I looked it up, it was a 6-inch, a 12-inch, and a 24-inch. That whole set right now is $300. Maybe cheaper on a different listing or from somewhere else, but I'm certain I didn't pay $300 for them. I think I paid half that for them, honestly, but that was 2 years ago. So hopefully, especially the individual who was curious how I did this, will get some benefit out of this. But anyone else too, putting a DRO on a machine like this is a little bit different, I think. You have to kind of think out of the box as to where to put stuff and how to connect stuff. And I do have wires running from the machine over to the control box, which is right there, not far away. But strangely enough, this machine actually has 2 Arduinos connected to it. That one runs the DRO, and on the other side of the machine, there's another whole Arduino set up with a power supply and motor driver, and that drives the X-axis, or I'm sorry, the Y-axis power feed, which I'll do a video on that some other time. So anyway, thanks for watching.